we're finally going to finish chapter 25, talking about the structure of the Milky Way galaxy. So now we're going to talk about population 1 and population 2 stars and explain why the globular clusters are the oldest structures in the galaxy. I said that like 2 chapters ago, but I didn't explain how we know that. So we're going to look again at this image of the Milky Way. Well, this is not an image of the Milky Way. It is an image that represents the Milky Way. Why is it that we do not have any pictures of the Milky Way galaxy? Well, from inside your eyeballs, can you see your face? No. Why? Because you're stuck inside it. We are stuck inside the Milky Way, and we will, be very, very far along in faster than light travel before we get any images of the Milky Way. So we have to look at other spiral galaxies and images of those and explain to ourselves how they are similar to our galaxy. So anyway, I'm getting lost in the details. When we look at a galaxy, here in the disk are stars like our star. So second, third, possibly even fourth, but later generation stars. Metal rich. So big stars blew up in the process. They created those heavier elements, the metals. That supernova cooled down, condensed into a new star that had metal in it. So metal rich. Out around the outer edges of the galaxy, we find globular clusters. And in the globular clusters, we find population 2 stars. They are called population 2 because we discovered them and why they're different later. In my head, it should be generation 1, generation 2. And so population 1, population 2, and that is not the way it works. So if your head says generation 1, generation 2, remember that star populations are backwards. The population 1 stars are younger and metal rich, second generation. The population 2 stars are older, metal poor, and population 1. So generation 1. Anyway, so how do stars move through the Milky Way? Well, in the disk, they orbit the disk, the center of the galaxy. But they don't orbit in a flat plate like a record. They bob a little bit. And why is that? So the disk of the galaxy is, attracting this star. And so it falls down to the disk of the galaxy. And then, it swings a little too far. So it swings down, comes back up, comes back down, comes back up. But they orbit in an organized manner, all in the same direction, bobbing along just slightly. The bulge stars do not agree with any kind of organization. They orbit in completely random orientations. And the same with the globular clusters. That is why Shapley was able to figure out where the center of the galaxy is, because if we watch this star and this star and this star, it's much easier to compare where the center is if those are oriented in different directions. And then let's talk about galaxy collapses and how we see that globular clusters and satellite galaxies are responding to our Milky Way. So the Number one model at the moment for how the Milky Way galaxy formed is called the monolithic collapse model. An enormous gas cloud was sitting out in space, and as things began to do, it was rotating. The halo stars and the globular clusters possibly were stars that formed and they were gravitationally attracted to each other, so they got left behind as the cloud condensed. It is also possible that they formed elsewhere in the galaxy and were attracted to this collapsing cloud. As anything that's spinning will flatten out. Two particles that come in from different angles collide and leave that collision more parallel than they started. Always. And so collapsing clouds end up as a disk. And so the disk stars formed later as the cloud collapsed enough to have density mostly in that disk. And they also were contaminated by the heavy metals from the first generation of stars in the disk. So really big stars, remember, big stars live fast, die fast. And so big stars formed, collapsed, supernova, threw metals out into the universe, and then that's when the population of stars that we see in the disk actually formed. And so collisions. Well, collisions cause bursts of star formation. This is one of my favorite galactic pictures. This is the antenna galaxies, and this is the picture that you almost always see. They never tell you that it's a zoom in from this, and this is a stream of stars that have been abandoned and left behind because the galaxies were moving together so fast because of their combined gravitational attraction. So what happens during galaxy collisions? Well, next week we're going to talk about the classes of galaxies: spiral, barred spiral, elliptical. When Hubble created those, he thought that a galaxy sits here all by itself and evolves and changes shape. And that is not at all what we have discovered. Instead, you will have two spiral galaxies that collide, and for a while it's a complete and utter mess, because they don't just collide and everything's done. The stars don't hit each other, they pass by each other, and so the galaxies will collide and swing around and come back together and swing around and swing around until they finally settle into an elliptical galaxy. You'll understand what that means next week. And so what trends do we see? Well, the big trend that we see is where galaxies are clustered together, there are a lot more elliptical galaxies than there are spirals. So we think that it's those collisions that have formed the spiral galaxies have collided to create ellipticals. And then when we look in even closer at those ellipticals, we see that the elliptical may have in its core several, it looks like baby galaxies, but more likely those are the active galactic nuclei, like our Sagittarius A star, and there are several of them that have collapsed and combined together to make that elliptical. When small galaxies are swallowed up by larger ones, as the small galaxy streams into the large galaxy, star formation and it leaves these streams of stars behind. Some of them may form into globular clusters where the stars have a whole, gravitational attraction of their own separate from the galaxy. And then, we're always finding new stuff. In 1994, a couple of British astronomers discovered that there is this dwarf galaxy falling into the center of our Milky Way galaxy. And then in the center of that dwarf galaxy, it looks like a globular cluster. So perhaps globular clusters, combine to make galaxies. We're still really not sure about several things along in here, but it's very interesting to watch the changing understanding, and that is what science is. Science is not a collection of knowledge. It is a collection of knowledge that makes you go, ooh, this and this seem to go together. Let's study that. And all of a sudden we have new understandings of the universe. So anyway, next week we will be talking about galaxy classification and Hubble.